statistical model is found to be. So there are four aspects that we need to examine about the bias: additivity and linearity, normality, homogeneity of variance, and independence of errors. When it comes to additivity and linearity, if the model is found to be biased because the model is fitting into a non-linear model, then we should examine using a non-linear model rather than a linear model. The second aspects, we know that the parameter estimates and errors should be normally distributed to help us to accurately determine the confidence interval, and for hypothesis testing and significant testing, the central limit theorem helps us with a larger sample size to mitigate the normality of those estimates and to focus more on the outliers and to get rid of outliers. In those situations, our focus should be how to deal with outliers. Third aspect is the homogeneity of variance or the outcome variable. We need to find out whether the outcome variance varies consistently across the change in independent variable for the outcome variable. And fourth is the independence of errors, that the errors have no dependence on the outcome variable or the independent variable. If the model is found to be nonlinear, then we can modify the statistical equation depending on the shape of the nonlinearity, whether it is quadratic, cubic, rectangular, hyperbola, exponential, logarithmic. We can then modify the linear equation using mathematical function, and it should match with the nonlinear behavior of the independent variable with the dependent. So if a given independent variable behaves nonlinearly with the dependent variable, we can use such function. But for the independent variable that has a linear relationship with the dependent variable on the same statistical model, we don't need to do any change. The second is when normality is being challenged with outliers. If the normality is disturbed by the outliers, there are four things that we can do. One is trim the data outliers, delete those extreme scores, and then use standard deviation or percentage of scores as a basis to analyze the remaining data. So it could be 3 standard deviations or 2 standard deviation or 50% of the population, mainstream population, the sample population that we are going to estimate and analyze. Second is winsorizing. Winsorizing is where we replace the value of the outliers with the highest value of the non-outlier. Third is to analyze using robust methods. We can use bootstrapping so that the bootstrapping will look at the normality of the sample estimates and do necessary adjustments accordingly. The fourth is to transform data with mathematical functions that corrects the data or the variable as we discussed earlier. The third is the homogeneity. If we find heterogeneity in the outcome variable, then we need to correct the standard error estimation. To correct the standard error estimation, we can use the option such as Huber-White standard errors or robust standard errors or sandwich estimator, so that we instruct the standard error of the mean to be correctly calculated under those heterogeneous circumstances. We can correct the variable parameter normality distribution using Box-Cox transformation to transform the variable parameter estimate to a normal distribution. Fourth is where we find that the errors are not independent. If we find the errors are not independent, that errors have a dependent relationship, for example, with the outcome variable, we can then mathematically change the outcome variable by a logarithmic function or a square root. We can also look at adding a nonlinear function to an existing independent variable and to see whether the independence of errors situation is correct. Another possibility is we add a new variable. Once a new variable is added, that independence of errors, the dependence of errors on the existing model variables could be eliminated. A fourth possibility is to find a new variable from an existing variable using a two-stage least square. Here, the value of the error terms is independent of the predictor variable is broken. So we're using the independent variable, existing independent variable, as an instrument variable to find a new variable. And once we have found that new variable, we are using that variable, new variable created from the instrument variable, at the second stage for the model estimation that replaces the existing variable with the new variable for the model estimation. So these are possibilities that exist when the model is found to be biased under the four aspects of model estimations.